Single and basic form conversions. Talking about sorts conversion, we're talking about converting semi-imperfect squares from their single form to their basic forms, and from their basic forms back to their single forms. When we talk about this form of conversion, we're talking about converting semi-imperfect squares, not full imperfect squares. Let's say, for example, semi-imperfect square of 8, that's square root of 8, we break it down to its basic form. Breaking it down to the basic form is like, for example, you're having a fraction of 6 over 8. To the basic form, or to the lowest term, you do 2 in 6, that's 3, 2 in 8, 4. To the lowest term, this is 3 over 4. That's breaking this fraction to the lowest term from 6 over 8 is 3 over 4. Similar applies to these single form sorts. Converting it from single form to basic form involves breaking it down to its product. Let's say we have our perfect squares here. We have 4, we have 9, that's 3 times 3, we have 16, that's 4 times 4, we have 25, that's 5 times 5. We don't need 1, we need from 4 upwards. Now, provided we can find 4 in 8, when you break it down to its product, that means we can break it down from this single form to the basic form. Let's just explain. You have 8 as also 4 times 2. Although 8 can be 1 times 8, but we need a perfect square greater than 1, which starts from 4. We can break 8 to its product as 4 times 2. And it is allowed in sorts, and we'll treat it that when you have situations of products under roots and they are linked by times or division, you can give them their separate roots. Unlike when you have addition or subtraction. What we're simply saying is you can have root 4 times root 2, or we say square root of 4 times square root of 2. The 4 can get its square root times square root of 2. That 2 also gets its square root. When it's addition, that's square root of 4 plus 2. You can't say square root of 4 plus square root of 2. It doesn't work. Or let's say it's negative. Let's say you have 4 minus 2. We can't say square root of 4 minus square root of 2. It doesn't work. It's not allowed in sorts. This is a rule you have to take note of. But when it's division, like 4 divided by 2, just like multiplication, you can say square root of 4 divided by square root of 2. It's allowed in sorts. Let's use a real example so we'll get it. Let's use 4 and 9. Square root of 4 times 9. Square root of 4 times 9. 4 times 9 is 36. Square root of 36 is 6. Now let's give them their separate square root and see if we get the same answer. We have square root of 4 times 9. We say square root of 4 times square root of 9. The 4 gets its separate square root times the 9 getting its separate square root. Square root of 4 is 2 times the square root of 9 is 3. 2 times 3 is 6. We see we have the same answer as when we multiply them first before we find their square root, or we give them separate square roots. We get the results for the separate square roots, then we multiply. We get the same answer, which is 6 here and 6 here. Back to the question, you have root 8 or square root of 8. We broke it down into its product that has a perfect square greater than 1, which is 4 times 2. At this point, since they are linked by times, we give them their separate square roots. We have square root of 4 and square root of 2. Square root of 4 is 2 times the square root of 2. We leave this as square root of 2 since we get a decimal. Because in sorts, we don't deal with decimals. We leave it like this. And in sorts, when you have 2 times root 2, you get 2 root 2. This is your answer in basic form. So we have it as 2 root 2. When they are linked by times, you just join them together. It's similar to algebra where you have 2 times a. 2 times a is 2a. You just join them together. Same applies with sorts. 2 times root 2 is 2 root 2. We've therefore successfully converted root 8 to 2 root 2. This is one way of converting it from single form to basic form. We also have another method of doing it, which I prefer and which I most time recommend to students. Due to the reason that students sometimes in certain questions might be incapable of getting out the highest perfect square in a number that is rooted or in a single form sort. So therefore, this second method is recommended. And how that works is we take the whole number under the root in the single form, we break it down to the product of its prime factors. Like the question says root 8. We take out the 8, we break it down to the product of its prime factors. We have 8 We have it here. You know what prime numbers are. Prime factors is gotten from prime numbers. And let's write our prime numbers. The first prime number is 2, not 1. We have 3, we have 5, and so on. So we start dividing by the prime number, starting from the lowest, if it can go through without a remainder. So we start with 2. 2 in 8, that's 8 divided by 2, that's 4. If 2 can still go, you still use it. 2 in 4. 2 in 4, or 4 divided by 2 is 2. 2 can still go in this 2. Then we'll go again, 2. 2 in 2, 1. Once you've gotten to this 1, you've gotten to the end of it. That's 8 as a product of its prime factors is 2 times 2 times 2. And when we're trying to convert it, in this case you have 2 here and you have 2 here. If you have two same numbers, you group them as 1. Then you multiply these 2. 2 times 2 is 4. So you have 4 as a perfect square, then you have it times 2. So we can say 8 is 4 times 2. Therefore you have root 8 as square root of 4 times 2. We've broken down root 8 into root 4 times 2, where we have 4 as our perfect square. And similar to this, we solve down. So we say square root of 4 times square root of 2. We give them their separate square roots. The square root of 4 is 2 times root 2. Root 2 gives you a decimal, so you leave it as root 2. You join together, that's 2 root 2. We've now solved another method, and we discovered the answer to root 8 as a single form to its basic surds form is 2 root 2. And good. Let's take another question. We're taking 3 questions. The next question is square root of 27. This is surd in its single form. Convert it to surd in its basic form. You have your perfect squares as 4, 9, 16, 25, 36, and so on. 4 can't go in 27. The next that can go in 27 is 9. And looking down, there's no other number less than 27 that can go in 27. So we'll stop at 9. So we'll take 9. Look at the number that you have to multiply by 9 to give you 27. That's 9 times 3. 9 times 3 is 27. 9 is a perfect square, but 3 is not a perfect square. You've broken 27 into a perfect square and an imperfect square. So we have it as square root of 9 times square root of 3. The 9 gets a separate square root and 3 gets its own separate square root. It's allowed when they are multiplying. Square root of 9 is 3 times square root of 3. You have your answer as 3 root 3 in its basic form. Let's take the third question. That's square root of 72. Your perfect square has 4, 9. There are others before, but in surds, this is what we need. Then you have 16, you have 25, you have 36, you have 49, and so on. Now in this case, 4 can go in 72. 4 can go in 72. That's 4 times 18 is 72. But even in this 18, you still have a perfect square, which is 9. So you can break this down into 4 times 9 times 2. You have to make sure, after breaking this into the first perfect square, you check the number behind. If you still have a perfect square in it, you break it down. So you have it as 4 times 9 times 2. This 9 can also go in 72. And it's also a perfect square. This is where you have to be careful. And the other method is very, very vital in this. And 4 times 9 is 36. So you have to pick the biggest factor of 72, which is also a perfect square, which is 36. 4 times 9 is 36. So this can be broken into 36 times 2. You can have 72 as 4 times 9 times 2. Each of them gets their separate square roots. Square root of 4 times square root of 9 times square root of 2. Square root of 4 is 2, square root of 9 is 3. And square root of 2 is a decimal, so you leave it like that. You have 2 times 3 is 6 times root 2 is 6 root 2 in its basic form. That's your final answer. And in the bigger picture, you have 36 taking charge. Let's say we have it as square root of 72, which is equals to square root of 36 times 2. Next, you give them their separate square roots. That's square root of 36 and square root of 2. Square root of 36 is 6 times square root of 2. You have it as 6 root 2. Now you can see you eventually get the same answer. The second method of breaking down 72 first into a product of its prime factors, then you group it. Now let's say we have square root of 72. Let's say you have square root of 72. In your rough book you have 72. You divide 72 by 2, you get 36. 2 by 36, you get 18. 2 can still go in 18, you get 9. 2 can go in 9, you go to 3. You use prime numbers in ascending order. You start from 2. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, and so on. So you go with 3 next. After 2, you have 3. 3 in 9, that's 3. 3 in 3 can still go in 3, 1. When you've gotten to 1, that means you've gotten to the end of it. So you have 72 as 2 times 2 times 2 times 3 times 3. And like I said earlier, you have to group them in 2s. You group these 2 in 2s. There's a third 2 here that cannot be paired. It's standing alone. Then you see they have 2 3s. Group them together. Then the ones that are in 2s, you multiply them together. You have 2 times 2 times 3 times 3. Then you put this 2 that stands out at the back times 2. Then you do 2 times 2 for 4 times 3, that's 12. 12 times 3, that's 36. You have this as 36 times 2. This forms the perfect square, and this is the imperfect square. So you have 72 as 36 times 2. Therefore, square root of 72 is square root of 36 times 2 at best, to its best form. So you have square root of 36 times square root of 2. Square root of 36 is 6 times square root of 2. You can have your final answer as 6 root 2. The same answer as those of the other 2 that we got. And I believe, except you feel otherwise, this is the best method of converting square root of 72 to its basic form, which is 6 root 2. So whichever method you're comfortable with, you can use. Basic to single form conversions. We know root 8 equals 2 root 2. We've converted from single form to the basic form. We can also convert from basic form back to single form. So we have 2 root 2. We have to convert it back to root 8. That's in its single form. How do we do that? 2 root 2 is also 2 times root 2. We're separating them back. That's 2 times root 2. These 2, we have to put in square root. Now you should know that the square root of 4 will give you 2. So we're taking these 2 back to its square root. You can just simply introduce a square root. The square root is simply 2 numbers that will multiply itself. So you take this 2 and multiply it by itself. That's 2 times 2. Now we've taken this 2, we're taking it back to its root form or its square root form. That you introduce a square root, you have 2 times 2. You make a second of it, then multiply them together. So you have 2 as square root of 2 times 2. If you are introducing a square root, you take the value. If it were to be 3, it will be 3 times 3. Then you still have times this root 2 times root 2. You go to the next step, you have your square root or your root, then 2 times 2 is 4 times root 2. We've taken this from square root of 2 times 2 to square root of 4. We join this to it times root 2. Since it's allowed, in this case, when they are linked by times, we can take them back in one square root. So you have it as square root of 4 times 2. The share is square root. Then you have your square root, then 4 times 2 is 8. So you have it as root 8 or square root of 8. We've successfully taken it back to its single form from its basic form. You might have a question where you have to convert from basic form back to single form. Let's take another one. Let's say you have 3 root 5. You can have them as 3 times root 5. They are linked by times. Then to take the 3 into square root, you introduce a square root. Then you double the 3 and make them multiply themselves. 3 times 3 times root 5. You still have your times root 5. Then you have your root. 3 times 3 is 9 times root 5. Is root 5, or square root of 5. You give them a big square root, then you join them together since they are linked by times. 9 times 5 under one root. Then you have that square root of 9 times 5, that's 45. We've converted this from basic form back to single form. We have 3 root 5 in the basic form as root 45 in its single form.